Okay, ni hao. Jiao Jackson Nick. And my Chinese is terrible. I try. I have a Duolingo subscription. I've been trying. Maybe next year. So I apologize. But it's a pleasure to be here. I always love coming to China. I especially love coming to KubeCon in China. And it's wonderful to see you all. And today I want to talk to you about network observability with Envoy. On my clicker, okay. So I'm a developer advocate. I work at a company called HashiCorp. And I've been playing around with service mesh and Envoy and sort of the whole observability sort of sphere for about 12 months, maybe 18 months now. And I found that there are some concepts which are pretty difficult to grasp. So what I want to do today is kind of give you an introduction on what observability is and how you can use an absolute myriad of metrics which come out of Envoy. And we're going to also take a look at tracing. And tracing is, I don't know whether you're using tracing or not, it's interesting. My background, I've used metrics for sort of basic statistics for about 5 years. And tracing is a slightly different concept. And we'll take a look at that. And very, very briefly, I want to look at logging. And that's kind of more so why this is actually really important in addition to all of the other stuff. All right. So why are we here? How have we kind of got ourselves into this situation where we need to be thinking about things like service mesh and network observability? Well, we're here because we've moved from static infrastructure to dynamic infrastructure. The whole world has changed. We've changed the way that we're managing services. We're now running Kubernetes, we're running multi-tenanted, we're running smaller services. And, you know, these things cause problems as well as solving problems. How do we get traffic east-west? How do we deal with things like network perimeter? And most importantly for this talk, how do we understand what's actually going on inside of that environment? So the market trend has been this move, right? And I wrote a book on microservices a couple of years ago, and I'm going to publish a new edition updating that hopefully this year. But one of the things that I see as a real benefit is this movement towards smaller functions of work. Smaller instances, smaller application instances, container-based services rather than huge monoliths. And there's a number of reasons why that's beneficial. It's easier to deploy. You're deploying smaller instances, lower risk. It allows collaboration. But it did require us to rethink pretty much completely how we manage and understand our systems. So the benefits of this, as I kind of said, is that productivity thing. You know, microservices I see are a developer tool. The benefit is to us who are working on the systems and coding them more so than a business tool. But there's also a business benefit in that if we can ship code quicker, we can get benefits to the end users quicker. But there's a cost as well, because you're deploying these multiple instances of services. Do you need like many different load balancers and different components of infrastructure? I'm not going to go into all of that today. But just some terminology before we begin, just in case anybody's kind of not familiar. So I'm going to be talking about Envoy, and Envoy is a component of a service mesh. So a service mesh generally built into two main components: a centralized and distributed control plane, and the data plane. So the data plane is where all of your traffic is flowing. Traffic doesn't flow independently from a service instance to another service instance. It's all proxied in and out through the data plane. Where that gives us benefit is that because the traffic's flowing through the data plane, we can understand better what's going on with regard to our network communications. And back onto that dynamic infrastructure thing, networks are not reliable. They're kind of pretty unreliable. So we've got to think about ways of mitigating that reliability. But before we can mitigate reliability, we've got to understand it. You can't do reliability unless you have observability. But observability, it's all over. All the blog posts, all the Twitters. Is it just a buzzword? What does anybody mean when they say the word observability? So by definition, observability comes from control theory. It's an engineering term, and it's kind of a measure of how well internal states of a system can be inferred from knowledge of external outputs. Like, what? Well, what we're trying to say is that if we measure internal inputs and outputs, we can determine an overall health of a system based on those. We can infer. And what does it encompass? So observability, this is kind of the key thing for me, that observability is not just about metrics or Envoy statistics. Observability encompasses all of this. So things like your Envoy statistics, application statistics, Kubernetes statistics, tracing, logging, health checks, business analytics, right? Don't forget this, but if you think about, if you want to measure the performance of a system based on its external inputs, then what about sales? Like, if a system isn't functioning correctly, you're going to see decreased sales potentially, or decreased traffic, or customer interaction. Those things are business metrics. They're not necessarily system properties, but observability tries to account for all of those. What we're going to be looking at is just a small part of that, and we're going to look at Envoy statistics and tracing mainly. So again, when we're thinking about observability, we've got to think about internal and external instrumentation. So we're going to be thinking about things like probes on Nagios, looking at disk space. All of these affect the behavior of the system. We're going to look at things like health checks. Again, it's an external check. But we're also going to be looking at application and network statistics. These are the things which are emitted from the internals of your system. So metrics. So when you want to understand metrics with Envoy, you've really got to first understand the architecture of Envoy, because if you look at the documentation, Envoy, it's just thousands and thousands of different metrics. And where do they come from? Right? So there's ultimately these 5 component parts. So we have things like listeners, listener filters, routers, clusters, and ultimately the control plane. So let's break those down. So a listener is something which is a named network location. So this can be something which your downstream clients connect into, but also something which you make a request outbound to. And Envoy is going to expose a number of different listeners in your setup. It's going to have a minimum of sort of 2, one for the control plane and one for the internals. But this is kind of another key term, and differentiating between the understanding of what is downstream and what is upstream. So downstream is a response and a request which comes from an end user client, so an external. So I could be a downstream source when I'm making a request to your website. Another service can be a downstream source. Whereas an upstream, this is something which is made to another service. And it's important to understand the difference between these two when we start getting into metrics, because a failure in an upstream doesn't necessarily mean a failure response code return to your downstream service, customer or user. And that's because of the reliability patterns which are potentially implemented somewhere in the filters there. A cluster, what a cluster is in terms of Envoy, it's a collection of endpoints. Now that could be either automated service discovery or it could be statically configured, but a cluster contains load balancers and it has a knowledge of endpoints for which it's going to route traffic. So let's look at the configuration. So Envoy metrics, depending on which kind of mesh you're using or whether you're not using a mesh at all, are pretty straightforward to configure. There's a couple of key things which I want to kind of point out and really sort of bring to your attention. And the first one is the ability to add custom tags. So we're going to look at this when we start looking at some of the metrics, but the key thing is around observability. You need to understand from where a metric or a statistic comes from, right? And being able to add additional bits of metadata to a metric is incredibly beneficial when you start to build up your dashboards and your alerts. The other important and I think absolutely essential configuration feature is this one here, which is using all default tags. Because if you look at the raw metrics or the raw statistics in terms of Envoy, they can be incredibly long. You'll have things like HTTP listener 192.168 underscore 8080 dot downstream underscore CX underscore blah, 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 right? It becomes incredibly difficult to manage those and build up dashboards when you're sort of dealing with something as complex. Whereas if you use this configuration element, what will happen is Envoy is going to extract things like the listener name or the cluster, and it's going to put it into a tag. So it makes selection of metrics much, much easier. Where we're going to kind of go with metrics, something important to point out is that Envoy has Prometheus metrics. It has the ability to expose a Prometheus endpoint, metrics endpoint, but there's a couple of caveats with it. So you really need histograms, and they are only available in Envoy 1.10. And the other key thing, which when I last checked the changelog, I don't think this has changed in 1.10, is that the Prometheus metrics are exposed on the admin endpoint. Now, the problem with that is if you make the admin endpoint for Envoy public, then not only can you get access to metrics, but you can reconfigure it. And that's kind of a bit of a security hole. There's a couple of ways around that. You can sort of set an internal Envoy route just to kind of loop back and expose only that specific Prometheus metrics point, but I believe that that's going to be either kind of modified or the admin endpoint in Envoy is going to be an authenticated endpoint at some point. So using metrics. So you've got a number of different ways in which you can kind of emit metrics from Envoy. The simplest is StatsD. StatsD has been around for a long, long time. Originally created by Etsy. It's a push-based metrics format which uses the UDP protocol. The key thing around StatsD is it doesn't support metadata, and we're going to kind of look at why that's important. You'll find that whichever sort of metric system you're using, they tend to support these kind of four things of counters, gauges, timings, and sets. Predominantly the first three are the most used. And it kind of looks like this. So the kind of the inherent problem there is because you don't support tags, the entire name or any metadata has to be encoded into the name of the metric itself. That can make querying, filtering incredibly cumbersome. That's a known problem. And it's a solved problem. So Datadog, who've got a really, really good SaaS-based metrics platform, introduced an extension to the statsd protocol, which is called dog-statsd. And again, it's that same format of push-based UDP, but dog-statsd introduces tags. So now what you can start doing is you can add metadata. So I can start building up, my service, so service a.myMethod.call.tags, and I can start putting the service ID into the metric. And that's really important because, again, you need to be thinking about how do you filter, how do you break down information. It's generally not an entire system of services which are going to have problems. It can be particular instances. So you need to be able to think about how to filter to a particular instance of a service, and tagging is essential. Prometheus, great open source, great CNCF project, takes a slightly different approach. So rather than you pushing metrics to the service, with Prometheus, what Prometheus will do, it will pull the metrics from your application. And that pull is done over HTTP, and importantly, it supports metadata. So again, those key things there, counters, simple things like number of requests. I want to see that break down over time. Gauges, what is the current CPU levels? Something which is kind of a fixed value. And histograms. Histograms really, really essential for being able to deal with timing data, because again, I don't want to be looking at averages. I need to be looking at things like quartiles and percentiles inside of my data. Metrics format, pretty simple, straightforward. Again, here's an example of an Envoy metric, and you can see here with Envoy HTTP Connection Manager prefix, I've got the name of my connection manager. Now, if I wasn't using tags, that would have been part of the name. So that use tags is a really, really important feature. So all those things, when you're choosing a format, you've kind of got to sort of take into all of those things into account. If you're using Prometheus, which I guess a lot of people do, then, you can kind of just go straight with Prometheus, but think about how you're accessing those metrics and that you're accessing them in a secure way because of the admin endpoint in Envoy. But ultimately, you can also send data out to dog-statsd, Datadog, and things like that, but you need to be thinking about metadata. And metadata needs to be more than just the service instance. You potentially want to be able to capture things like the Kubernetes node. You want to be able to capture the pod name, the deployment sort of ID. As much information as you can, which will help you in the event that you need it. And this is kind of the key thing. You kind of got to capture a little bit more than you think you need right now, because you never know what you need until you find out you don't have it. Right. Okay, so listener metrics. So things like downstream connections. And I've just kind of pulled out some of the key elements here. That there are a huge number, but these are some of the things that I like to kind of monitor. And again, don't forget that, because I need to be able to get that metadata. When I want to kind of build that up into a Prometheus query, so I can look at something like the connection total. So that's a counter. So I want to be able to see maybe a bar chart or a graph of the number of requests. With counters, I tend to like to see those rather than a rate. I want to see the number of requests. So I tend to use increase instead of a rate there, but I'm in either way breaking it into a 30-second bucket. When you start to kind of view that information, you can kind of, connections, are they really that useful? I think so. I mean, the key thing you've got to remember with a connection is that internally Envoy is using connection pooling. So you do not have a one-to-one relationship between a connection and a request. But connections are really interesting to monitor because connections should be somewhat static, right? Because that connection pool is being maintained. If you're seeing a lot of connections created and destroyed, it can be an indication that potentially there is something in the system which is not allowing persistent connections. Persistent connections gives you speed. That's why we kind of use connection pooling and persistent connections. There's also some key metrics around connections which I think are really good for alerts. And the kind of the key one which I've highlighted here is SSL fail verify no cert. So within the sort of the context of your service mesh, all of your traffic should be using MTLS. So it's using an encrypted transport and it's using client-side certificates to manage authentication. If you get a lot of errors around that, then that could be a potential problem where you need to think about the configuration of your service mesh. So that's a kind of a good health warning. So what about requests? So requests, you've got to be thinking about layer 7. Right? And again, we're going to break up requests into downstream and upstream. And remember that difference. A downstream is, to me, back to your end consumer. The upstream is something which is happening internal in Envoy. So an upstream failure does not necessarily result in a downstream failure because of the retry patterns and the reliability. But downstream is really important because that's what your end user sees. Failures on the downstream means that your end user is suffering. Again, looking at some of those things, we've got like downstream requests underscore 1xx and 2xx and 3xx. Stats tags, it changes a lot of those things. So we'll take a look at that in a second. When we're using stats tags, what we're going to be able to do is use a metric like this. So I'm using the downstream request, and because I've got that enable stats tags on Envoy, I've got request underscore xx as my metric name rather than this great big list, right? So that gives me the capability, because it's extracted that response code as a tag. And Envoy understands the HTTP protocol, so it understands HTTP response codes. And I can see there that Envoy will inject the tag response code class. And it allows me to build up a differentiation. So I can say, well, I'm only interested in errors, or I'm only interested in things which are not errors. Because a 404, is it an error? Probably not. A 404 could be, it's not an internal error. Looking at those kind of things on a chart, I can actually plot them, and I can stack them as a bar if I want, and I can kind of see the various different response codes, or I can split them up. But I've got that flexibility to be able to do that. Now, request errors, this kind of goes without saying, but this is really, really important to be monitoring request errors. And you should potentially have alerts as well around request errors. I know it happens, but it's something which is undesirable. It's your end user which is affected, right? Especially on a downstream. So, for example, if I'm monitoring my request errors, I start a new version of my pod, and all of a sudden I go from 0 request errors to a whole bunch of them. Now I can configure an alert on that, which is looking at a percentile increase. That's giving me early warning that the new version that I've just deployed is not working as requested. Timing. Timing is incredibly important, and we want to be looking at things like timing. And timing, what we want to look at are things like the histograms, because we want to be looking at, say, the 99th percentile. So 1% of the users are experiencing a time of this sort of level. Majoritarily, you're going to be kind of looking at the 50th percentile, so where the majority of your users are. But you want to be breaking those things down. Means are somewhat useful, but the sort of histograms and looking at histograms is so much more descriptive when you're looking at the sort of the technical performance of your system. But what about gRPC? So gRPC is HTTP, right? HTTP 2. Yeah? But it's not. Well, it's kinda. It uses it as the transport, but gRPC doesn't honor things like HTTP status codes. With gRPC, what you're doing is you're encoding the status code into the protobuf response. So when it comes to building your metrics, I could have a failed request, which is an internal server error, potentially, in my service, which is still going to get response as an HTTP 200. And luckily for us, Envoy understands the gRPC protocol, and Envoy can actually decode both the method call and also the response code. So to enable that, it does have to be specifically enabled. We use this feature, which is an HTTP filter in Envoy, and it's the HTTP 1 bridge filter. Now, if you look at the documentation is pretty clear on what this thing does, but when it's easy to misunderstand. So a lot of people look at the HTTP 1 bridge filter and say, well, it's a method of translating an HTTP request into a gRPC request. And it does that. But it also allows Envoy to understand response codes, the methods, the encoded data inside of the protobuf, and to report that into your statistics. So I can use things like this. And again, you can kind of see here, I've got Envoy cluster gRPC, so this is a metric, a statistic. And then I've got the gRPC response code. So 0, that's the equivalent of an HTTP 200. I've got a response code 5 here. This is kind of the equivalent of a 404. And gRPC status codes don't directly map to HTTP status codes. But again, building that up into a chart, I can build something which is really, really rich. I can filter on that status code, but I'm also seeing the method call. So I can actually isolate those independent requests, which is really, really nice and useful to see. I've just lumped them all into a single chart here, but you can kind of break them up as you need to. Errors, again, I'm using a different metric, but in the same way as I'm dealing with HTTP requests, I want to deal with gRPC errors. But again, remember, a gRPC request can complete with a 200 but still be an error because of the status codes. So cluster metrics. Cluster metrics, we're kind of getting into things like the upstream requests. And upstream requests are internal in Envoy. And we need to differentiate between upstream and downstream because, as I mentioned, if you're using a pattern like a retry, then you could have multiple upstream failures but a downstream success. You need to monitor them independently. We can kind of see here that we've got some retries and we've got some errors. I've applied the retry policy, so I can see that Envoy again is putting my retries there. Now these retries wouldn't result in a downstream error, but they are manifesting themselves as an upstream error. Timeouts. We need to monitor timeouts. So a timeout in the system is a big red flag. I tend to put alerts on timeouts, and whether you have that go straight through to PagerDuty or not, like that's up to you. But I think a timeout is a big red flag, and you need to be carefully sort of monitoring this information. And if you're kind of implementing those reliability patterns, you've got to be thinking about like monitoring outlier ejection. So what does outlier ejection do? Like as a pattern, if Envoy receives a number of status codes from an endpoint which result in a failure, it will remove that endpoint from the cluster temporarily. So here I'm monitoring that those endpoints have been ejected. I might have one particular service which is a little bit sort of flaky, but Envoy will remove it temporarily. Then you can see the gap, because Envoy is going to try it again. It's going to give it time to recover. But then in the second block, Envoy said, hey, I've got errors again. So it's going to remove it for a longer period. But again, outlier injection, this is something which I think should be both monitored, but also configured for alerting. Auth-C. So the way that kind of the authorization works, so again, two components, authentication and authorization. Authentication is done through the MTLS process, client-side certificates. Authorization is a facet of the control plane, so it's an additional layer. I have this presented entity, is it allowed to connect to me? This is a metric that you really want to be monitoring inside of your control plane, because you kind of got to be thinking about why would you get these failures. You should never really get Auth-C failures. There's a kind of a bunch of metrics, again, so the total responses, but ultimately I'm kind of mainly interested in errors, and I'm looking at OKs. So why am I interested in those two things? The first reason is that when I start a new pod, I'm going to spawn a whole load of new connections. So I should see a little spike in authorizations, but they're cached. If you see constant authorizations for a service, then there's something not behaving itself correctly. Authorization is going to slow down your service. So you don't want to see many authorization requests at any period of time. Authorization failures, this is a massive red flag. So you've got to be thinking about authorization failures. Why are you getting those? There's two kind of predominant reasons. The first one is that you've got misconfiguration, so you haven't actually explicitly allowed service communication between two services, or it could be somebody who's probing around in your system and trying to do something that they shouldn't. And on to tracing. So tracing is interesting. I'm kind of growing in my appreciation for it. As I said, it's something that's different to me. And I just took this from the Open Tracing website, but it's a nice description. And the thing that's interesting about tracing is when you're looking at performance. So the configuration of tracing in Envoy requires that you set up a cluster. And you've got to set up the cluster because Envoy needs to know where it is going to send the tracing data to, the spans. Your control plane should handle this for you, but it's interesting to know, I think. And you also need tracing configuration because there's a number of different drivers which Envoy can use. It can use a Zipkin driver, which is kind of open tracing. There's some new stuff in 1.10 which allows pluggable open tracing, and it'll also support open census, I believe. You've got Lightstep. But when you start to look at a tracing, so here's an example of an HTTP post, I can actually see visually the different kind of the paths or the different sort of network hops that have gone through my service. So I've got internal from the downstream to an upstream listener, and then I've got a gRPC service. What you've kind of got to be reticent of when you're thinking about tracing is that an external call, all tracings have a parent-child relationship. And if this is an example for Zipkin, but you've got to be thinking about forwarding the headers, because if you receive if you make an internal call from your code, you've got to forward on the span IDs and the tracing IDs for it to be registered as part of that graph. It's pretty straightforward in HTTP. gRPC, again, we've got to be thinking about things differently. We're not using the HTTP protocol in the same way. But what we do with gRPC is we extract those headers, and I'm extracting them from an HTTP request, and I'm adding them as metadata to the upstream context. The open tracing and gRPC, there's some great frameworks which work as middleware to help you do this, but essentially that's what they're doing. They're taking the parent information and they're adding it to the child span in order for that nice chart to work. Lastly, on logging. Why is logging useful if you've got all of these wonderful metrics? Well, when I was kind of putting together this presentation and working on my demo, I couldn't get my tracing to work. And my metrics weren't telling me anything. But when I looked in my logs, I could clearly see that my logs, I wasn't sending the spans. So you've got to think about all of those things. Envoy is going to give you some great information around access logs, everything at once, all of the things. I want to thank you so much for listening to me today, and I'm going to be around the conference. If there's any questions you've got, I'd be more than happy to answer them. Thank you so much. Oh, yes.
I have one question. What's your recommended way to send the tracing? Is your prefer to send the tracing directly to Zipkin or Jaeger backend, or by some Istio mixer?
Yeah. So what's my preferred way to send tracing? Is it direct or is it via the Istio mixer? So I think Istio mixer, and correct me on this, but I believe there's going to be some changes, because when you send everything through Istio mixer, one of the performance bottlenecks in Istio is with mixer. And I believe that there's going to be a separation from mixer as a centralized component in an up-and-coming release. So you can absolutely send them direct to Zipkin, or you send them via a collector, which acts as a proxy. So I run generally a collector as a service. So I've just got like a deployment with a number of instances. But I think it's very much dependent on the direction of where Istio goes around using Mixer right now.
I don't see in your slides about the gRPC metric.
Yes.
Yeah, that shows that the HV is yeah, back. And back. Not tracing, metric.
Oh, sorry.
gRPC metric.
We'll get there.
Yeah.
Okay.
It's only post measure,
So these are the. Sorry, this is a little bit misleading. I've actually named the gRPC methods put, get, and exists, because the service in question here is actually storing some data, or it's retrieving. Yeah, sorry. Not HTTP, sorry. In retrospect, those are terrible names, but no, they're actually gRPC methods, not HTTP methods. All right, thank you so much.
Hi.